discussion.
So how did you get to the number of 150 VMs per physical machine?
Oh, 150 containers?
Yeah, 150.
Well, we use our site experience monitor to check for contention, and when there's too much contention, we launch more instances and rebalance. And this is kind of the sweet spot where we've been able to run that many, and not all of them are the same size slice of the system, but the average size of the slice was about 200 megabytes of RAM. And these are 30 gig boxes. And I think we're moving to 64 gig boxes soon for those systems.
105 MB, the apps are WordPress and Drupal.
I'm sorry?
105 MB each. So the apps, what are the apps?
The apps are Drupal and WordPress, and the two kind of containers I was showing on there are the ones we use for MariaDB/MySQL, and for a combination of Nginx, PHP FPM, and a file system client mount, which is what we call an app server.
If I want to run a database that has more than one process associated, I mean, Oracle has what, 6 or 9 or whatever, would all those processes run in one container, or would they have to have 9 containers that somehow but they don't talk to each other?
Well, containers can talk to each other. Like you can flip on or off any of these isolation bits, basically. But one of the beauties of C groups is that when you have a process that is put into a C group, any of its children automatically go into that C group. So, and that's kind of handled and enforced by the kernel as a matter of security. So if you start Oracle, even if it's just a temporary process that it uses to start up other things, everything that, the world that it starts up, all 9 processes will be in the same C group and the same namespace, because they're both inherited.
Okay. With the million containers you have running, are those spun up via your own custom code with using C groups?
Well, we apply the C groups configuration through systemd. So when I say container, we're actually running .service units that have namespaces and C groups and other security isolation enabled on them. So they're using the same kernel facilities as, say, a Docker container would, but it's just called a service in systemd if you configure it that way.
So you mentioned OpenBZ just briefly at the end. What did you say about that really does not put it in the category of container?
I can't quite hear your question.
You only briefly mentioned OpenBZ. What about it does not qualify to?
Well, one of the main things, I don't know if this is true anymore because I've heard that this may have changed, but it was not possible to use it with the vanilla kernel for the longest time. So you would have to run a large kernel patch, or your distro might ship a separate OpenBZ kernel, and a lot of people don't like that for security reasons, for administrative reasons, for compatibility reasons. The nice thing about the technologies that I've been covering in here is they're all usable with a vanilla kernel.
So if I fire up this process and it's using the disk, it has access to certain directories, are those directories then somehow invisible to everybody else on the machine? Or like, are my disks virtual or somehow protected from other users?
You're in terms of file system namespaces?
Yeah, I guess so.
So file system namespaces are a very interesting thing because they produce a lot of unexpected results, because there are certain files you'll see when inside the container and certain ones you won't. And to be honest, I've only used file system namespaces for 2 things. Isolating temporary files for applications, which is an option systemd provides for all services, where you can basically say private TMP yes, and it'll create a new directory, and then what it'll do is it will create a namespace, and then it will mount, I forget the mount command, that basically just does a kind of pass-through to that directory as /tmp within that namespace. And then everything that gets written to /tmp in that namespace gets written to the base file system in the directory that was mounted there. So I still think everything needs a representation on the base OS if it's going to be writable. And then the other thing we do is within the namespace, we nix certain directories, like /etc is usually nixed by us for inside the container, which means it's not even visible, let alone usable from a kind of Unix permissions perspective.
Are you doing a container per service, like a container for your web server, container for your database server?
We are right now. So when I say an app server, it's actually 3 different kind of separately isolated things from a namespace, C group, etc. perspective. In practice, each service has its own kind of favorite thing to exhaust first. Like Nginx tends to not exhaust anything except network on its own. PHP FPM tends to exhaust CPU. MySQL tends to exhaust block IO, and to a lesser degree CPU. And we don't use the memory controllers, so that's not something I can really go into details with. And then, so we do run kind of separate ones, and then they basically are running in their own containers, although any child processes and threads by each one are running in that same container with it.
So do you so when you start off with a new container, do you bootstrap, chef, and then run your configuration management, or do you have kind of like a pre-baked container file system and then some hosted thing?
We run Chef directly. We actually run Chef not in the container, but on the base system targeted at the container directory. And then that puts the right things in to initialize the container, drops the service units on the base system, and then it's ready to go. And then when I say that when it times container being provisioned, that's when Chef has finished up and enabled the services on the base system, and then if a connection comes in, it'll properly bring that container daemon online and service the request. Although we want to get away from that. We actually want to move more toward the Docker model of having kind of images that get sent down to containers.
So let's say you're having a problem with the running container. Do you actually just like SSH into it, or do you just close them all in, or how do you?
I can speak toward the systemd thing. There's some neat stuff that we did into. Let's see, there it is. What we're doing now is we're providing a lot more transparency into containers, where basically there's a command to take a shell into the container. I actually don't think it's on this page, the command to do that, but you do not have to SSH into the container, because you can, all namespaces have a corresponding file descriptor identifier that can be tracked by the container management layer, and then you can tell something to basically enter that namespace by using that file descriptor, which can be passed around various ways on Unix systems. And so with the right careful handling of, you initialize the namespace, you save the file descriptor, which is a numeric identifier that represents a kind of handle in the kernel, then you can basically enter that without SSHing. You could run an SSH server though in the container, in the kind of virtual machine tradition, but it's possible to join things in. We actually added a feature to, I think, systemd 2.10 or 2.11 called joins namespace of, which allows you to launch one service, and then you can say another service and say joins namespace of, service A, and then when that second service starts up, it'll actually join in the kind of world of the first service that was starting, and it'll do that for network namespace, and file system namespace, and like one other one. I think there's actually incomplete coverage, like for the kernel APIs right now, for joining existing namespaces. I don't think you can do it for all namespace types yet.
I have 2 questions. The first question is there any advantage to sort of, so you said you're sort of like dealing with the systemd processes like and file namespaces and that like yourself on the core system. Is there any advantage to doing that versus using Docker? I mean, you said you guys are sort of planning on moving to a Docker.
Yeah.
That system is.
We implemented our stuff about 2 years
Right.
before Docker
Right.
had any that was even named
Right.
as a project. So we started implementing our current generation of our infrastructure, I want to say around 2011, maybe early 2012, when we made our main technology decisions, which systemd was around, it was in Fedora,
Right.
And that provided at least a way where we didn't have to completely cobble together our own stuff. The main advantage of having it on the base system right now that we're waiting on for Docker, and I know some Red Hat engineers are working on fixing this gap in functionality, but we use socket activation for all these things where systemd is listening on a socket, a connection comes in, we start the service, it's handed in as a file descriptor, and that works perfectly with systemd services. But Docker containers don't fully support it yet, even running within a systemd service the way that CoreOS or Red Hat's Gear D do it. But that'll change. It was working before, and then it broke, and then they're working on fixing it again, and hopefully it'll be actually like treated as part of something that gets tested before release and is stable. But I think that's the last big gap for us wanting to take a more mainstream container system.
And then I had one other question, going back to like the file system question, and maybe this is just specific to systemd, but I still wasn't quite clear on like, if you're dropped into systemd and you're doing things with like file namespaces, and you're doing things in like this isolation container, and if you were to then log in as like into the root OS and outside of systemd completely, would you be able to see like all of the things that those namespaces created, like that those files?
Well, anything that gets created in a namespace I believe has to have some corresponding directory on the real base system.
Okay, is that how Docker works as well?
Docker, so originally Docker was using, so Docker was originally using a kernel facility that was compiled in on Ubuntu systems but was not part of vanilla kernels to do the file system. And then they changed to device mapper so that they would have compatibility with vanilla kernels.
Was that the layered file system that they're using?
They were using...
AUFS?
Yes, that was what they were using. And that is not part of the vanilla kernel, and is not shipped on Red Hat flavor systems or several other distros. And then they switched to device mapper for being able to have the file system in the container, and I don't know any more details than that about how they're actually using device mapper to provide that in the container. I have heard that if device mapper is mapping the same libraries and executables to multiple containers, it only gets loaded into RAM once in the base system, which is also part of our goal, because if we're packing 150 things basically running the same application, one thing we don't want to have is we don't want that application's executable and libraries to get loaded into RAM for every instance.
Right.
It's just redundant.
Yeah, but then you also don't want, obviously, the containers stepping on each other's toes as far as files are concerned.
Yes.
Yeah.
So the file systems under Docker are all stored, I think, in file lib Docker, and then the ID of the image or the container, and so they're all sort of split out that way. So if you're root on the host OS, you can see all of the files.
Yeah, I believe they all have to have regardless of namespacing. I don't think that file system implementation.
As an operations guy, how do I keep track of application topologies, the network graphs, all of those things? What tools are out there? How are you guys doing it at Pantheon?
So we do. I can go into kind of a few things. So at Pantheon, what we do is on our core API, we have this concept of an environment stack, where every site that deploys on Pantheon has multiple isolated environments, development, testing, live, possibly some dynamically spun up ones if users request it. And then each of those has a set of resources in them that we call bindings. And bindings could either be kind of credentials for external services, or they could be services that are going to run in a container on a specific host system in our infrastructure. And then all of the configuration that's happening with Chef for one of these containers uses a certificate for that container that corresponds to that environment and is able to look up other resources in that environment and see what systems they live on and what credentials to use for them or what certificates to use for them. And then it configures that into there. So we don't have any kind of complex, say, IP tables, rules, or tunneling going on. It's mostly, here's the destination IP, here's the destination port that corresponds to the right container on the destination system. So you may find out that the database master server for this particular stack in this environment has the database on 10.0.0.1 port 5000. and then it'll connect that when it needs that, and it's able to pull the credentials or use a cert to connect to it. Docker had, since I played with it, it's changed, but they have a concept of connecting to other containers in the infrastructure and kind of providing rules for them to connect. And I think it directly configures IP tables on the same system so that they can connect to each other if they need to connect within a box. And then I know what they were trying to do the last code sprint I did with them was they had this thing that they called the ambassador pattern, where the idea was that there would be some agent running on the box that would know how to contact the right remote service wherever it lived, even if it moved. And then the application running in the container would talk to the ambassador, which would then connect to the right remote service. And the reason they wanted to do it this way is the obvious choice, which is like DNS. Too many things try to circumvent DNS lookups in the sense of a lot of applications may try to go to root servers or their own preferred recursive resolvers, and it's hard to kind of control the DNS lookups for applications. So their idea was like, well, we'll just provide a hard IP address and port, probably on localhost, and then it'll just talk the right thing. And then I know OpenShift has their own method of interconnection between their containers, which I didn't even mention their container format. They're moving to Docker. Right now they have this kind of weird like namespace SE Linux thing that they do, which is unique to OpenShift. But they're probably closer to Pantheon's model in the sense that they have a kind of directory of destinations, and they'll configure those destinations inside the container and usually inject them to the application with environmental variables so that the application can read those to know where to connect, or use those environmental variables to configure template files that are configuration for the data or service.
The Chef server is your state server for all that then?
No, we don't actually run a Chef server. We run Chef Solo on all these boxes with a plugin that uses certificates to talk to our core API.
What's keeping state?
Our core API, which is Twisted Typhon and Cassandra. The reason why we do that versus like say Chef server is that even basic operations that our users do often require reconfiguration of containers. So we have to have super high availability for the configuration services. So our core API with Cassandra and Twisted is no single point of failure, no coordinated kind of failover decision to make, no master. If it can talk to any of those three nodes, then it's going to be able to accomplish its configuration task. Facebook actually runs Chef in a similar way. I believe they run Chef Solo with plugins to talk to services that provide state information.
They keep their state in version control, push it to the Chef server.
Oh, do they?
Yeah, they don't have any, no state ever changes on the server.
Oh, okay. So they do run Chef server then?
Yes.
But do they run locally on those boxes, or?
They run a lot of them.
Okay, they just run a lot of them. Okay. Yes.
The socket activation, I didn't quite get that. It sounds like it's sort of sleeping, and you say it was also taking memory, but it's not taking CPU?
So let me just pull up a, let's see, here it is. So I did a presentation that included a section on this. We had the challenge of kind of PHP FPM, even when it's sitting idle and just listening on its socket, it's actually eating up a tiny bit of CPU. Even if it's eating up 0.1% of CPU, packing 10,000 of those in a box is not a non-starter. We use a full PHP FPM instance per container because that isolates the opcode cache, it isolates all sorts of other wonky things about PHP FPM that you don't really want to share between competing users. It took 0.5% of a core, which that's not good. What we did is, I'll just provide, so traditional sockets, the application that's listening opens the socket, it does a kind of bind, listen, accept pattern in Unix, where bind is where it actually kind of opens up that particular IP address and port number, listen is where it puts it into a kind of server mode, where the OS now or the kernel realizes that any connections coming into that particular socket are kind of designed to be accepted by the application. And then accept, if you're doing blocking programming, it's just kind of a loop where accept blocks until a connection comes in, and then it can process it. And then async programming is a little different, where you separate the listener and the accept, but that doesn't affect socket application. So traditionally, a daemon starts itself up, listens on a socket, accepts connections. There's no interaction except between the daemon and the kernel. Socket activation is where systemd gets configured to squat on that socket on behalf of the daemon, where basically systemd can say, I want to bind onto and listen on, say, port 80 all interfaces. And then what happens is the systemd puts an epoll listener onto that socket. And the nice thing about epoll is that it can get the event of a connection coming in, but the thing that processes the event of the connection coming in doesn't have to be the thing that actually accepts the connection. So systemd will get the event of the thing coming in, it'll start up the service that is corresponding to that socket or set of sockets, and then Unix provides the ability to hand off a file descriptor. Like when you do bind and listen, you get a file descriptor that represents the thing that you would be accepting connections off of. Just like if you opened up a file, there are many things in the kernel that provide file descriptors besides files. Sockets are one of them. Systemd will hand this in to the daemon as file descriptor 3, or 3, 4, 5 if you say you're listening to 3 different sockets. The reason it starts at 3 is the first 3 file descriptors, 0, 1, and 2, are standard in, standard out, and standard error, even for services. That's just kind of defined as part of Unix. And then it'll hand that into the daemon, and then the daemon can immediately go into its accept loop, or it can set its own kind of event listener on there for the fact that it needs to do accept. And then as soon as the daemon takes over that file descriptor and starts doing its accept loop, it's actually directly communicating with the client through the kernel. It's not, systemd is not proxying the traffic. Systemd has given the handle over to someone else, to the daemon, and then the daemon's able to kind of operate in the same way as if it had actually done the bind and listen process itself. And this is kind of neat because it's kind of like capability-based security. You can actually put the daemon into a network namespace where it can't see anything except its like fake localhost, and you can hand in the listener, and if the only thing it needs to function is as a server listening on a socket and handling requests, it can do that without actually having the ability to create any outbound connections or bind to the socket itself. And that allows doing neat things like, even if you don't want to use network namespaces, you can do neat things like have systemd listen on port 80, and you can start your web server with already dropped permissions, because it does not need to start with elevated permissions, because the thing that started the listener on port 80 is systemd, not the web server, and then it'll hand in the socket, and the web server can mosey along as if it had opened up port 80. You don't have to wait until the first connection comes in, though. You can do it eagerly, where it creates the listener and systemd starts the daemon, hands it in, even if no one has tried to connect to it.
So, in a set up this dynamic, what do you use to monitor what's going on, and then how do you do capacity planning?
With the site experience monitor, where we basically run a representative workload, there's a Drupal site that runs on every server that has a database, an application server, an Nginx, and then every minute or so, maybe more frequent than that, we're basically running a couple kind of user transactions through that application. And if the disk I/O or the CPU or anything else is starting to get under contention, the score is going to drop. And we have thresholds for initial threshold that it hits is going to be kind of no new containers. And then another threshold is migrate containers away from this server. And then another threshold is alert ops.
Okay, so you don't necessarily know what it's running out of. You just know it's running out of something, so you're going to move containers off.
We have separate monitors for each of the resources directly, but we take the site experience monitor especially seriously because it's running a representative workload. And if that's running poorly, then we know that the customers on that box are going to have a compromised experience.
Can you talk about what you mean by migrating a container? Is that sort of like a, VM world where you're, doing a migration there, or is it you're literally just starting something out of that?
It's depends on how much state is associated with the container. There are some folks who have done, especially actually in the Parallels OpenVZ world, they're working on the kind of process state freeze and migrate, which is much more like the VM style migration. In our case, what we do is we have a process called mutiny in our system. And it's called mutiny because what we do is we start by creating a replica of the original container, like using MySQL master slave, or say Redis replica, or Solr replica, etc. And then when it copies over the state and then achieves parity with the primary server, then it basically says, I'm ready. And it doesn't matter what, the process up to this point doesn't matter whether we're creating a replica for horizontal scalability, or high availability, or for migration. It's the same process. And then when it checks in, it has a bit set on it for whether to be mutinous or not. And if it has the mutiny bit set on it, it means that when the replica has achieved parity with the primary server, it issues a call to the API called mutiny, which switches control to the replica and then reconverges everything that is necessary to point to the new primary, and then the other one is basically axed.
What happens to like client connections that are still going to the old replica of that?
We don't kill any client connections. So the replication is continuing up to and beyond the point of actually doing the switchover, and then the clients are getting reconfigured to point to the new replica, or the replica server that's about to become primary. And so there's a certain window of time where some requests may be going to one and some to the other. And then after all of them have reported back in that they've converged over to the new soon-to-be primary server, that's when we actually axe that other one.
So does that imply you have some sort of like load balancer and all this to make it safer, or?
No, it's configured for each of the application servers. There's a small window of inconsistent time, but for web applications, it hasn't been an issue. You would have to have a fairly carefully constructed write to do something where it would conflict in a way where writing it to the server and writing it to the server would have caused a replication conflict during that small window of time. We have yet to see it with our customer base. I wouldn't do it that way if we were, say, running financial transactions. I would do a much more atomic switch over.
So with your Cassandra config range that you have for your chef nodes,
Mm-hmm.
have you looked at like newer tools like etcd or Surf or any of those, or are you happy with what you have?
The problem I don't like with, I know etcd has done, the CoreOS folks have done some work on this, but we have a very strong philosophy of defense in depth for our systems in terms of compromise a container, it's contained there, compromise to get root access in the box, you compromise the box but not our infrastructure. And a lot of systems like etcd have a real problem with that latter part of if you compromise a box, have you compromised the infrastructure? In our case, we use public key infrastructure certificates so that each machine only has the authority to talk to the core API about the resources that are assigned to that machine and the sites that are that have presence on that machine. And so compromising a machine in our infrastructure, which is considerably easier than for a lot of infrastructures, given that we're running user code on our machines, which automatically gets past the first barrier that most people have on their systems. That if a user's running code on most people's systems, that means you've been hacked. So we use that as a defense in depth strategy so that we prevent compromise of one box from meaning a global compromise. I think if you compromise an etcd instance, you're basically able to send whatever you want to the other etcd instances and feedback. That may have improved, or may require a certain threshold to be compromised, but there's no inherent barrier there because it's entirely kind of peer-to-peer mutual communication.
So once etcd adds like servants, between them?
I'm not sure. Like, one thing we've looked at is maybe doing a partition infrastructure where maybe we have a pool of like 10 nodes and they're all in kind of one etcd setup, and 10 nodes over here that are on etcd, so that we can at least compartmentalize any kind of breach. But we definitely don't want to have all of our servers running with etcd. Also, a consensus algorithm across hundreds of servers would be a problem.
Yeah, they're adding a pool of them.
Okay.
But yeah.
You have Hadoop customers?
I'm sorry?
You have Hadoop customers?
I
Hadoop customers?
Hadoop.
Oh, no, we don't have any Hadoop system.
Is that everyone?
I think so.
Okay, David Strauss. All right. And just this, you guys. So, first of all, behind all of this is a guy named Lynn Bender who now lives in San Francisco because he can't stand the allergies he experiences here. Imagine that. Lynn Bender is Geek Austin. He is the primary organizer of this. He is the guy who organized tonight. Please, get on the site, make a message, say thanks, Lynn. I know he appreciates that. We are bigger than the sum of our parts. One of those parts is Matt Ray. What, coming? He's handsome. And he's also the brains behind Chef Cafe. So, each month, Matt provides 2 hours of his own time, office hours. You want to know about Chef? You have a question about Chef DK? You want to know what's going on with Chef? Why they changed their name to Chef? Because that's searchable. This is the man to ask. Please watch the site if you're using Chef or you're thinking about Chef. Is Byron Miller here? So Byron just got Puppet started. He probably wants to know.
Now that he's talking heresy.
So I'm going to call it Puppet Show. I don't know if it has an official name yet. So Byron is doing the same thing. Again, Jeff, did you happen to go? Did anybody go to who's here, go to the first Puppet morning thing? How'd it go?
Pretty productive. I like it.
Fantastic. All right, so we now have a correlate for Puppet. A very good friend of mine just went to work for Ansible. I'm hoping to leverage that for Ansible. Okay, I've never been able to get those guys to call me back, so I'm hoping now that I have a friend there, he'll call me back. Be kind of sad if he won't. Atlassian has moved to town. I see Atlassian as a huge DevOps tool because of all the communication stuff with Bamboo and HipChat and everything. So I'm going to talk. So what I'd like to know is there an interest in maybe an Atlassian subgroup? Yeah? No? All right. What about Ansible?
They started an Atlassian meetup actually here in town.
Okay. Well, go there. Ansible has a meetup, I'm pretty sure, right? So what we can bring is to these organizations is we have 550 and growing members, and so a lot of them will do a subgroup. It gives them a chance to say we're doing this, and all of you guys see it. And if you're interested in that particular tool, you get to take the time, to say, hey boss, I'm going to go learn something cool. See ya. All right. So say your last name, Jeff.
Carpathian.
Jeff Carpathian is taping this tonight. If you have friends who didn't get here, we'll tweet it out, we'll post it, we'll make sure that this gets up. Jeff just showed up with his camera. Jeff, you rock. Thank you. Jeff and his dad are getting consulting practice up off the ground. Hire them. Rovi is Adam Tuckman. Where are you go, Adam? Right on. One of our sponsors. Thank you very much. And we are now going to adjourn over the next 15 minutes or so as we move out and be social to the Pour House. P-O-U-R House. It's about 3 miles from here. It's over kind of on Burnett. Great beers, a really nice outside area. So let's try and be out of here by 9 to respect the Rackspace folks who need to clear us out before they can go home. And let's get over to the Pour House, drink some beers, and ask some more questions, network a bit more. David, will you make it over?
I actually need to head downtown.
Okay. All right. So.
Anywhere